Okay, so what we're going to do here is we are going to identify what are called the intervals of increase and the intervals of decrease. And then we can also put along with that intervals where the graph is constant. And so we would be referring to this as the function f of x or g of x or something like that. And then we're also going to identify what are called local maximums, local minimums, and then the what could be called the absolute maximum, the absolute minimum, and then the domain and the range. When we're identifying intervals of increase and intervals of decrease and the constant intervals, we are going to be focusing on x values, that's this direction. And then when we do the local maximums, the local minimums, and the maximum and minimum, we're going to be focusing on y values, which is this direction, okay? Then of course the domain is going to be x values, and the range is going to be y values, okay? So let's go ahead and see what's going on here. So an interval of increase is an interval, like an x interval, like, like starting at 4 and going up to 10, okay? It's an interval where the graph is going upward, okay? And so because increase means, as we increase in x value, increase would mean that we're increasing in y value. So we're going this way, okay? But an interval of decrease would say that as we travel along the x, we would then be decreasing. We would be going down. And so just to give you an idea, this is an interval of increase. This is an interval of decrease. This is an interval of increase. This is an interval of decrease. And this is an interval of increase. The idea is as we travel from left to right, okay, so from left to right, are we going uphill or downhill? Uphill or downhill or uphill? If we're going uphill, then it's an interval of increase. So there's an interval of increase, here's an interval of increase, and here's an interval of increase. If we're going downhill, then it's an interval of decrease. This is also an interval of decrease. However, we do have these places where it neither goes up or down. It's flat, and that would be an interval where it's constant. That would be a constant interval, okay? And so when we say what are the intervals of increase, we're looking for this one here. So here's an interval of increase, and we're doing it in x values. It starts here, and it ends here. So it starts increasing at -9, and when we get to -6, that's when it stops increasing. And so our first interval of increase is going to be let me change to the pen here. The first interval of increase is going to be from -9 up to -6. Now we always do intervals of increase and decrease with parentheses. We don't do brackets, okay? And then our next interval of increase, you'll see, is starts here and ends right here. But we don't care about the y values. We only care about the x values. So we start at -1, and then we go up to, let's undo that. And we go up to 2 here. So the next interval of increase starts at -1 and goes up to an x value of 2. And so we're going to say, there's a couple ways we can do this. We can either say union and then -1 up to 2. The other thing that we could do is we could just put a comma. Okay, so we can just put -9 to -6, comma, -1 to 2. And different homework systems and different homework questions will require something different. So sometimes you'll have a question that wants you to put in a union, and sometimes you'll have a question that wants you to put in a comma. All right, and so now you can also see here that we've got this interval of increase here. It starts here at x equals 4, and it ends here at x equals 7, okay? And so our last interval of increase is going to be from 4 up to 7. So we're going to union, and we're going to say 4 up to 7. So we have 3 intervals of increase on this graph. -9 to -6, -1 to 2, and 4 to 7. What about that constant interval? Well, that's this flat spot here. And it starts at -6 and it goes up to -3. So we're going to say that there's a constant interval from -6 up to -3. And there's only one constant interval, so we're only going to put that one. Then intervals of decrease. That's where the graph is going from a larger y value to a smaller y value as we go to the right. See, at -3, we have 2. We have a y value of 2. But at -2, we have a y value of 0. And then at -1, we have a y value of -2. So the y values are getting smaller and smaller as the x values are getting larger and larger. So this is an interval of decrease, and it starts at -3, and it stops here at an x value of -1. So our first interval of increase is -3 up to -1. All right, and then we have an interval of decrease that starts here, and that's an x of 2, and then it stops here at an x of 4. So our other interval of increase, for this one I'll put a comma, is going to start at 2, and it's going to go up to 4. And now we want to identify the local maximums. A local maximum means that it's a point where no point around it has a higher value. So like this is a local maximum here because there aren't, right in this immediate area, there are no other higher values. So this is a local maximum and it's at a y value of 4. So we have a local maximum at 4. Interestingly though, look at this. This constant thing, even though they're not higher than each other, they're also not lower than each other. And so along a constant interval, we have the whole thing is nothing but considered to be maximums and minimums. So there's a whole set of maximums between -6 and -3, okay, at what height? At a height of 2. And so another local maximum is 2. So we'll say 2 and 4 are the 2 local maximums, here and here. If we do the same thing for local minimums, you can see that if we go to this spot right here at -1, -2, even though there are lower points on the graph here, in the immediate area, this is the lowest point, and therefore we have a local minimum at -2. -2. Also, the constant is also a whole set of local minimums because no other set or no other point around it is lower than it, and so 2 also represents a local minimum. And then lastly is this spot down here, and it's a -6, and so we have a local minimum at -6. Now when we want to identify the absolute maximum, what we're looking for is the absolute highest point. So are there any points higher than this? Yes. Well, this is the highest point in the whole graph. Look at that. And so because that's the highest point in the whole graph, it's the maximum point of the whole graph. And so when we say the maximum, we're going to say 4. And usually the maximum is going to come from the group of local maximums. Same thing for the minimum. It's going to come from the group of local minimums. This is the lowest point of the whole graph right here, which is -6. And so the minimum of the whole graph is -6. Now we're just going to identify the domain and range. The range is actually really easy. The range just runs from the minimum to the maximum, the lowest point, -6, up to the highest point, 4. So the range is going to be -6 up to 4, and we use brackets because those numbers are included. The domain is going to be the farthest left to the farthest right, which looks like -9 all the way over here to +7. But look at this. Do you see this closed circle? This closed circle here on 7 means that 7 is included. But this open circle on -9 means that -9 is not included. And so on the domain, we're going to do -9 not included, so we did the parenthesis, up to 7 with a bracket because 7 is included. Okay. right, let's just do one more example. I've got this one right here. And so if we start with the intervals of increase, now look at this right here. This graph runs off. It goes all the way to negative infinity. And this graph right here, this keeps going up and it goes all the way to positive infinity. So it's going to keep going up and up and up and up, okay? And that's important. So if we're looking for intervals of increase, okay, well, this is a constant, this is a decrease. Here we go, we have an interval of increase here, starts at -3 and it goes up to -1. So we're going to say -3 to -1. And then look at this, decrease, decrease, and here we're increasing starting at 4, and look, we're increasing all, and it just keeps going. It's just going to keep going up all the way to infinity. So our other interval of increase is going to be 4 up to infinity. And then as far as constant goes, we do have an interval of constant, and it's right here. It ends, it starts at negative infinity and it comes all the way up and then ends at -6. So our constant interval goes from negative infinity up to -6, and it's going to include, or I'm sorry, intervals do not include, we don't do inclusive. Intervals are always open circles, or open parentheses. But intervals of decrease, you can see that it's decreasing here from -6 to -3. And it's also decreasing here starting at -1 and going all the way down until 4. Okay, so -1, -3, sorry, -6 to -3. And then -1 up to 4. That's our intervals of decrease. And then our local maximums, well, here's a local maximum at 4. This whole constant is a local maximum at 5, and that looks like that's all we have. So local max at 4 and 5. Local minimums. Well, we know that the constant is also a local minimum, so 5. We have a local minimum right here. Look, it goes down then up. This is a local minimum, so that's 2. And then down here we have a local minimum where it goes down and then up, and that's at -6. So we have a local minimum at -6 and at 2 and at 5. Okay? And so now when we want to identify our overall maximum, I want to show you something here. Because this interval of increase goes to infinity, this line keeps going up and up and up all the way to infinity, and therefore there is no maximum. And so for a maximum, we'll say none. But minimum, there is a lowest point. Look, right here, this is the lowest point of the whole graph. And so the minimum point is -6. And now if we want to identify the domain, well, look at this. We go all the way back to negative infinity. Up here, we're including here. We're picking back up here. It looks like every x value is represented. So the domain is going to be negative infinity to positive infinity, and the range, now the range, the lowest we go here is -6. See, look at that, -6, and there's no maximum. So no maximum means that it goes up to infinity. So the range is going to start, well, the range is actually going to include -6, so I'll do a bracket. It's going to start at -6 and it's going to go up to infinity. Okay, and that's it for being able to identify these features of graphs, and I hope this helps a little bit.